Okay, welcome back everybody. I appear to be having lighting issues right now, so I'm going to use this yellow paper. It seems to be working a bit better. It's about 9 o'clock in the evening here, so I'm using one of these document cameras from one of the classrooms. Well, actually, IT lent it to me. So, but it's very sensitive to light and it pulsates with the white paper, so I'm using this yellow paper instead. So hopefully this goes okay. Alright, so this topic's going to be finding the least common multiple of polynomial expressions, of two or more polynomial expressions. Okay, so let's just start with a numerical example here. As usual, we're doing LCMs of polynomial expressions. The least common multiple of polynomial expressions, and we'll just start with a numerical example, as I said. Okay, so for example, let's find the least common multiple of 8 and 12. Okay, now this is in Unit 1 of the textbook if you want to go back and read about that, but you know, I think I'm going to take a bit of a different spin here. Okay, so what is a least common multiple? Well, it's the smallest number such that 8 and 12 divide that number evenly, or we won't have any decimals when we divide it, okay? Alright, so how can we find it? Well, one way is just to look at the multiples of 8. You know, the multiples of 8 are 8, 16, 24, and then look at the multiples of 12. Well, we've got 12, and then 12 times 2 is 24. Okay, so the multiples of 8, again, are 8, 16. I just make a list going up like that. And then the multiples of 12 are just 12, 24. And as soon as you get a match, you know that's the least common multiple. Alright, now if we look at the prime factorization for these numbers, for 24, 8, and 12, what do we see? Well, 24 has this prime factorization. It's 8 times 3, which is just 2 times 2 times 2 times 3, which is the same as 2 cubed times 3. Now if I look at the prime factorization for 12, well, 12 is just 4 times 3, which is just 2 times 2 times 3, pardon me, which is the same as 2 squared times 3, like that. Okay, now finally, if we look at the prime factorization of 8, we get 8 is 2 times 2 times 2, which is the same as 2 cubed. Okay, now as I said, the least common multiple of 8 and 12 is the smallest number such that 8 and 12 both divide it evenly. So take a look here. Does 2 squared times 3 divide 2 cubed times 3? Well, it sure does. We'd be left over with one factor of 2 if we did that division. Or 24 divided by 12 is 2. Now if I do it with 8, well, this divided by 2 cubed would just be 3. 24 divided by 8 is 3. We'd have one factor of 3 left over. Okay, so what's the idea here? Well, the idea is simple. When I'm trying to find the least common multiples, when I'm trying to find the least common multiple of two numbers, I just take the highest exponent appearing on any one of its on any prime factor shown anywhere. Okay, so the first thing I would do is I'd check against the 2's, and I'd see, well, this one has a 2 cubed, so I'd use that as part of my least common multiple. Now this one doesn't have a 3, but this one does, a 3 to the power of 1, so I would include that in my as part of my least common multiple. And that's just so that when we try dividing them, we'll be left with integer results. Okay, so I must admit this is a bit hard for students to see sometimes, but the idea is the same for polynomial expressions. Okay, but it's a bit more obvious, I think, for a lot of people. So let's just go straight into some examples here. Okay, now As it turns out, polynomials, if I take all the possible polynomials out there, we could also give them prime factorizations, and that's just factoring them the way we normally would. Okay? All right, so let's just look at some examples here. I think you'll see it's fairly straightforward. It's almost more obvious looking with polynomials. Okay, find the least common multiple, the LCM of x plus 1 times x minus 1 and x plus 1 times x minus 2. Okay, well, I mean, again, I'm just looking for something, or I'm looking for the smallest common multiple of these two things such that both of them divide it, okay? Well, if I look at this, I can just say to myself, well, x plus 1 is common to both of them, so I should definitely include an x plus 1. And maybe we should use some notation here. So the LCM of these two things, these two polynomials, is equal to x plus 1. Now, I need to include, just like with the prime factorizations, I need to include the highest power of any factor appearing. Okay, so they both had x plus 1 to the power of 1, so we had to include that. This one has an x minus 1 to the power of 1, so we should include that, even though that one doesn't have it. And now this one has x minus 2 to the power of 2, so we should include that as well. Okay, and as you can see, this divides this perfectly. If I divide this by this, I'll be left with x minus 2, and this divides this perfectly. If I divide this by this, I'll be left with x minus 1. So we've achieved what we wanted to achieve here. Okay, so, and again, just to restate it one more time, you just take the highest power appearing on any factor. Okay, so for example, let's find the LCM of x plus 3 squared times x plus 1 and x plus 3 times x plus 1 squared. Okay, well, if I compare these two things, again, all I have to do is take the highest exponent appearing on any of the factors. So therefore, the LCM is equal to, well, I compare the x plus 3's. This one is the highest power of x plus 3, so I should include that. And then I compare the x plus 1's, and I see that this one has an x plus 1 squared, so I should include that. Okay, and maybe if you just want to confirm that this and this divide that, then go ahead and do that. So if I divide this by this, what would I get? Well, the x plus 3 squared would cancel out, and then x plus 1 squared divided by x plus 1 would just leave me with a single factor of x plus 1. Okay, so I've basically feeling pretty confident now that I've achieved the result that I'm looking for. Okay, last example, and then we'll call it quits on this video. Find the LCM of x plus 1 times x plus 2 squared times x minus 3 and 2 times x plus 1 sorry, that got a bit messy there, times x plus 2 times x minus 3 cubed. Okay, so again, just look for the highest exponent appearing on any prime factor. So, of course, this one needs to be included, the 2, because this one doesn't have a 2. So therefore 2 to the power of 1 is the highest exponent on that factor. And then I compare the x plus 1s. Well, x plus 1 and x plus 1, they both have a power of 1, so we'll include a single power of x plus 1 there. And then I compare those. I see that this one has an x plus 2 squared. So I'll make x plus 2 all squared as part of my least common multiple. And then finally we should use this cubic factor. X minus 3 cubed. Since this is to the power of 1, that's to the power of 3, we should use x minus 3 to the power of 3. And that's it. Okay, now in general, for these homework questions I'm about to give you, you should do page 293. Okay, but when you're doing this page, make sure to factor everything. Make sure to factor. When finding LCMs. Okay, great. And that's that for that video. So the next topic will be adding and subtracting rational expressions. And I can see we're going to make some great progress here at this rate.